Imagine a cat, a flask of poison, and a radioactive source all inside a box. Is the cat alive or dead? This is the perplexing question posed by physicist Erwin Schrödinger's famous thought experiment, Schrödinger's cat. Picture this. A sealed box houses a cat, a vial of poison, a Geiger counter, and a radioactive source. The fate of the cat hinges on a random subatomic event. In the strange world of quantum mechanics, the cat is both alive and dead until someone checks. This odd situation arises from a quantum phenomenon known as superposition. Now, what does that mean? Well, let's take a little dive into the world of quantum physics. You see, in this bizarre world, things don't behave as they do in our everyday lives. Superposition is the idea that a quantum particle can exist in multiple states at once. Imagine you're flipping a coin. In our world, it's either heads or tails, right? But in the quantum world, it's as if the coin is both heads and tails at the same time until you look at it. Sounds crazy, doesn't it? Now let's apply this to our feline friend in the box. According to quantum superposition, the cat is both alive and dead at the same time. It's in a superposition of states. It's not one or the other, it's both. Just like the coin being both heads and tails. But here's where it gets even stranger. The act of observing, of opening the box to check on the cat, collapses this superposition. It forces the universe to make a choice. And it's at this point that the cat becomes either definitively alive or definitively dead. The cat's fate remains uncertain until the box is opened. Only then does it choose to be alive or dead. And this, my friends, is the paradoxical world of quantum mechanics in a nutshell. Or should we say, in a box. So, who decides if the cat lives or dies? You do. In the paradox of Schrödinger's cat, the act of observation plays a pivotal role. Picture this. The cat in the box is both alive and dead at the same time, a state we call superposition in quantum mechanics. But the moment you peek into the box, the superposition collapses. The cat is forced into one state or the other, alive or dead. This is not just a peculiarity of a thought experiment. It's a fundamental aspect of quantum mechanics. The act of observation determines the state of a quantum system. This might sound strange, but welcome to the world of quantum physics, where the conventional rules of reality often don't apply. In this world, the observer has the power. The observer influences the outcome. So when it comes to Schrödinger's cat, the answer lies with you. In the quantum world, it's not a question of what is, but rather what you observe. This thought experiment is a gateway to the fascinating world of quantum mechanics. Schrödinger's cat isn't just a fascinating paradox. It's a cornerstone of our understanding of the quantum world. It brings to light the concept of quantum superposition, which is one of the fundamental principles of quantum mechanics. In quantum superposition, particles can be in multiple states simultaneously, just like our hypothetical feline friend who is both alive and dead until observed. This leads us to another intriguing aspect of quantum mechanics, the observer effect. The very act of observing influences the observed, collapsing the quantum superposition into one definite state. It's as if nature keeps her cards close to her chest, revealing them only when we decide to look. Now, the quantum world doesn't stop at superposition. It's a realm teeming with other bewildering phenomena. Take quantum entanglement, for instance, where two particles become so intimately linked that the state of one instantaneously affects the other, no matter the distance between them. Imagine being able to feel the same sensation as your friend who's halfway across the world, instantaneously. That's quantum entanglement for you. Then there's quantum teleportation, which sounds like a sci-fi concept, but is very much a reality in the quantum realm. It's a process where the information of one particle is transferred to another without any physical movement. It's not quite beam me up, Scotty, but it's still pretty mind-boggling. These concepts, while challenging to comprehend, are the building blocks of our understanding of the universe at its most fundamental level. The quantum world is like a magician's hat, brimming with mysteries and surprises that defy our everyday logic and understanding. The enigma of Schrödinger's cat continues to perplex scientists, and it's just one of the many mysteries of the quantum world waiting to be explored. So come on this journey with us as we delve deeper into the rabbit hole of quantum mechanics. Who knows what other wonders we might uncover?